Here is a question from JEST 2013. Before going into the problem, let us make sure that you remember the relativistic velocity addition formula, which says velocity of A with respect to B. This is equal to VA minus VB divided by 1 minus VA VB upon C square. Now you have to make sure that the velocity of A and B are measured with respect to the same frame. So if you take O frame here, then you have to take O frame here as well. So this is the relativistic velocity addition formula. We will be using this after some time. This is a very important formula. Now in this problem we have a light beam. Which is propagating through a block of glass with refractive index n. So there is a block of glass and its refractive index is n. There is a light beam moving inside it. The speed of it will be c by n. So velocity of light with respect to glass block, this is equal to c by n. Glass is moving at constant velocity v in the same direction as the light beam. So this glass block, it is moving in the same direction as light beam with a velocity v. Therefore we can write velocity of glass block with respect to the ground, with respect to the laboratory frame. Let us denote lab by s. Lab is s. So velocity of glass block with respect to the S frame, the laboratory frame, it is equal to V. Now you know that VAB is equal to minus VBA. Therefore I can write VSG, velocity of the ground or the laboratory, is with respect to the glass block is equal to minus V. Now the question is asking for the velocity of light in the glass block as measured by an observer in the laboratory. So the question is asking for VLS, velocity of light with respect to lab. This is equal to, if we apply the relativistic velocity addition formula, VLS is equal to VL minus VS divided by 1 minus VL Vs upon c square. Now VL and Vs should be measured with respect to same frame. So let's take the glass block. So VLG is equal to c by n. Let us put it here, c by n, minus VSG is equal to minus V divided by 1 minus c by n, this is VLG, VSG is minus V upon c square. So this is coming out to be equal to c by n plus V times 1 plus V by NC, the whole raised to minus 1. Now since V by NC is a small quantity, we can write this as VLS can be written as c by n plus V times 1 minus V by NC, because you know this, right? 1 plus x, the whole raised to n, this is approximately equal to 1 plus nx if x is small. That is what we are using here. Then we will get VLS is equal to c by n plus V into 1 minus V by NC, which is equal to, let's write it here, VLS, velocity of light with respect to the ground or laboratory, this is equal to c by n plus V into 1 minus v by nc. This is equal to c by n plus v minus v by n square minus b square by nc. Now this can be neglected. This is very small, as b is very less than c. This is neglected. This implies VLS is equal to c by n plus v into 1 minus 1 by n square. Correct answer here is option A.